Hello. So the name of our team is Neural Nexus, and the topic of our presentation is speech augmentation. The motivation for this are low resource languages. These are the languages for which very less data is available for training some models. And if we are to create data for these languages, we would have to hire multiple speakers and then process that speech data and all. So it can get a little bit expensive, but our approach makes it relatively cheaper compared to the traditional method. This approach can also be used for those languages where very limited amount of speakers are available, for example, Sanskrit or some other endangered or near to extinct languages. So this table here um, shows the comparison of word error rate of of some different models, which uh, here there is comparison between the models which are trained using human data, human speech data, synthesized speech data, and both human and synthesized speech data. So the word error rate, as you can see here from the models trained with only human data and the models trained with only synthesized data, the gap between the word error rates is too high. But if the models in which human and synthesized both data are used combinedly, the word error rates gets too low, even lower than the models which are trained only with the human data. So this gives us a kind of hope for our models to train in these languages, where we have very less amount of data available. So we can use this approach of training these SR models using human and synthesized data. So we can close the gap between the word error rate. Also, this approach will provide accessibility to those who are currently excluded from the use of these technologies.
Yes, so some relevant work, first paper by NVIDIA published in 2018. They use synthetic speech data from TTS to augment Libre speech dataset so that training with both real plus synthetic speech improves recognition performance. Focus on demonstrating the basic effectiveness of synthetic augmentation. It is limited to monolingual settings and not for low resources. The second paper published by Google, published in 2019, focused on making synthetic data closer to real speech distribution, explore algorithms to provide the necessary acoustic and lexical diversity needed for robust speech recognition. They also focus on high resource languages. Third paper published in 2020 showed that using TTS-based data augmentation can improve end-to-end ASR without requirement of huge amount of real expensive data. Again, the limitations are it is not cross-lingual, and the paper assumes that TTS exists for the target languages.
So basically, we are now focusing on what different we are doing. So in this paper, the basic difference which we are providing is single speaker requirement. So here we have a single speaker, and that with the help of that single speaker, we are making a multiple speaker voices. So we are augmenting the data in a way that a single speaker is there, and we can generate multiple audio recording from that. And we also provide in this paper we are also providing cross-lingual augmentation. In this we are speaking in a one language, and we can augment the data in different languages also. It fills the performance gap when we are using only the human data. Like in previous paper it was discussed, like they are using a large libresis data, so that in that the word error rate was very high. But when we are using the combination of synthetic data and human data, the error reduces.
Okay, so what this paper uniquely contributes, I can say, is it employs combines the two techniques like cross-lingual multi-speaker text-to-speech and cross-lingual voice conversion. So what happens when you do this both is like let's say you have, let's say, only a single language, single speaker data set in a low resource language. So even though you have that small amount of data, still you can highly make it effective method of the speech augmentation. What you can do is you can create the single speaker data to multi-speaker data set, and then how you can do that using this voice conversion technique. So you if when it was done and they compared this with their baseline model, like they had taken baseline as their data set, which was a single speaker one, and their upper bound was common voice and the data set which was used earlier. So here what they did was they did the experiment with three languages. They had the data set trained, they trained their text to speech model on the English data set, on a large English data set, and they took Brazilian language, Brazilian Portuguese language, and the Russian language. So they had this very small amount of data set of the other two languages, and using the English data set, using the kind of transfer learning, they created the two different augmentation technique mixture. And then they what they showed in the result was, if you have the baseline and the data augmented data with the experiments which they do, you can see here the word error rate for Portuguese and Russian drastically drops, even though it's not less than the upper bound. But upper bound is considered like you have lot amount of data. But if you have very less amount of data, which this is in this case which they took, still the improvement is very significant, you can say. So yeah, this is the contribution which came from major contribution which came from this paper.
Okay, so as Prathamesh was saying about the contribution, like how the word error rate drastically dropped when we did some data augmentation. So I'll just talk about the complete pipeline, like how they did all that. So over here we can see, so what we have UTTS, and what we're doing is, first of all, we are training that UTTS with multi-speaker English data. And at the same time, we are also using some single speaker TTS data for Portuguese and Russian language. But as you can see, like the multi-speaker English data is huge over here compared to the single speaker TTS data for Portuguese and Russian language. So first of all, we are training the TTS using these data sets, and we are generating the speaker embeddings for that. After that, what we get? We get a model checkpoint. So using that checkpoint, we are using the English speaker embeddings to create two different type of data set. So first, what we are doing, we are doing the TTS inference. That is the text to speech inference. So over there, what we are putting is as input, we are giving a common voice data set for Portuguese and Russian language. From there, we are picking up the texts, and at the same time, we are also using the English embeddings from the model checkpoint and putting it all to the TTS inference. And after that, we get a Gen TTS dataset, which can be used again. Again, there is a VC inference over here, and over there we are using the single speaker TTS dataset, that is the Portuguese one and the Russian one. Along with that, we are also using that same English speaker embeddings to generate a Gen VC dataset. Then at the same time, like we are using like this Gen TTS dataset, Gen VC dataset, and the single speaker TTS dataset, like for the Portuguese and Russian language, and we are giving it all to wake, which is an ASR. And at the same time, we are also doing some kind of audio augmentation, like changing the pitch, timbre, and everything. And finally, we are evaluating that, I mean, on the basis of word error rate using the common voice Portuguese and Russian data set. That is a huge data set. So can we go back to the previous slide, Prathamesh? Yeah. So as Prathamesh was explaining, like as we include the Gen TTS dataset and the Gen VC dataset, along with the normal TTS single speaker dataset, we can see the word error rate is decreasing drastically. So, I mean, that's how the pipeline works over here. Yeah, that's all from my side.
So, with respect to this paper, our group will try to implement two future means two things. One is we'll implement this paper on Indian datasets, that is Indian languages, basically Marathi and Bengali. And the second new feature or novelty which we are trying to do is on the data augmentation side. So basically, what we are trying to do is we take phone conversion data set, which is Gramvani in Hindi. So basically, when two people are speaking on a phone, there is a channel through which the data is transferred. So we'll try to get the channel characteristics. So what kind of channel characteristics are there on a phone conversion is bandwidth, codec, and sampling rate, and the rate at which the data is transferred. So we can get this channel characteristics from the phone conversation data set, that is gram one, which we are taking. And once we get this channel characteristic, we'll try to create a system or a filter which will mimic the channel. So basically, if we try to pass the data on through this system, it will try the output which we'll get will be mimicked as if the two people are speaking. So we are trying. So what we'll do is, so we'll get Bengali and Marathi data set, and the channel system or the filter which you have created will pass through this data to this uh, to this filter, and the output which we'll get is the augmented data for this phonic conversation, and we'll pass this data to this ASR model, and we'll get a word error rate. And the second thing which we are going to do is the TTS generated speech which we are having. We'll also again pass through this to the filter, and we'll get again a new augmented data. And this will also pass through ASR model, and we'll get a new word error rate. So this will be good for comparing different word error rate for our project.
So what we are planning first to divide our team into two parts. First, we'll be spending our 3 weeks in collecting the database and collecting all the data parts. Then one team will start preparing the data augmentation block, and the other team will start training the TTS model as they have trained in your TTS. Then uh, in one in about 1 month, we'll be done by creating our data augmentation block and the TTS model. Then we'll go to the ASR model and train our ASR model on both data augmented data as well as TTS augmented data. And then after in the conclusion in the last month of our semester, we'll be testing the WER and concluding our experimentation.